Solar engineering runs on units, and one mix-up can wreck a whole calculation. The most common confusion of all is between power and energy, so let us settle it for good. Power is a rate measured in watts, how fast energy moves right now. Energy is the amount that piles up over time, measured in watt-hours. A 5 kilowatt system running flat out for 4.5 hours makes 22.5 kilowatt hours. The link is simple. Energy equals power multiplied by time. Hold on to that one relationship and most unit mistakes simply disappear. Sunlight gets its own shorthand, peak sun hours. It is the number of hours of full 1000 watt per square meter sun that would deliver the same daily energy. 5.4 kilowatt hours on a square meter equals 5.4 peak sun hours. Two more cousins get muddled. Radiance is the instant brightness in watts per square meter, what a sensor reads at this moment. Irradiation is the total gathered over the day in kilowatt hours per square meter. To compare systems fairly, we use specific yield, kilowatt hours produced per kilowatt peak installed each year. 1500 kilowatt hours per kilowatt peak means every unit of capacity earns its keep, whatever the system size. Finally, heat 3 labels apart. Kilowatt peak is the panel's DC rating under standard test conditions. Kilowatt is the inverter's AC output to the grid. And kilowatt hour is the energy actually produced. They are not interchangeable. So power is a rate and energy is a total. Peak sun hours pack the whole day into one number, and the peak, the output, and the energy each have their own unit. Get the units right and the rest of the maths follows.